All right, welcome to today's Explainer. We are jumping straight into something absolutely wild today. We're decoding a truly revolutionary piece of military tech, a system that essentially takes a massive truck-mounted radar hunting array and literally shrinks it down into a single backpack. We're talking about the ELINT system. It's a massive innovation that fundamentally changes how soldiers perceive the invisible threats all around them. Here is our quick mission briefing for today. We're going to cover the invisible battlefield, meet the backpack radar hunter itself, dissect the tech, look at its AI brain, and finally, break down the massive tactical advantage it gives out in the field. Okay, kicking things off with Section 1, the invisible battlefield, hunting the unseen. So ask yourself, how do you hunt an enemy that you literally cannot see? That is the absolute biggest problem in modern electronic warfare right now. Today's battlefields, whether you're up at the high-altitude line of actual control or deep in some dense counterinsurgency jungle, are completely saturated with invisible threats. We're talking drone control links buzzing overhead, multi-band surveillance radars sweeping the area, highly encrypted tactical radios hopping all over the frequencies. To the naked eye, a mountainside might look totally empty, but in the electromagnetic spectrum, it is a glowing, pulsing war zone. Before we get too deep, let's quickly define a couple of acronyms you're going to hear a lot. ELINT, which is Electronic Intelligence, and ESM, Electronic Support Measures. Basically, both of these refer to passively intercepting, identifying, and geolocating enemy electronic signals. Notice I said passively. You weren't shooting out a radar beam and giving away your location like traditional systems do. You were just listening, very, very closely. Now, traditionally, doing this was a massive headache. Legacy systems were huge. We're talking mounted on trucks, weighing well over 40 kilos, and they could only listen to really narrow slices of frequencies at one time. I mean, imagine being an Indian Army soldier patrolling at 18,000 feet. You can't exactly drag a truck full of servers up a Himalayan peak. The solution we're looking at today completely flips the script. It had to be man-portable, weigh under 15 kilos, and cover the entire spectrum from 30 megahertz all the way up to 40 gigahertz. Which brings us to Section 2, the Backpack Radar Hunter. Let's introduce the ELINT. Designed by Defense Systems, this thing is a total game changer. Out in the field, it puts wideband electronic intelligence literally onto the back of an individual soldier. This means a single squad can hunt down and geolocate enemy signals on the move, without needing a massive, slow vehicle convoy backing them up. And since no two missions are ever exactly the same, the system comes in two setups. First, you've got the S1. This is for the solo operator. It's super light, just 12 to 15 kilos, and it's optimized for sneaky, fast-moving counterinsurgency or intelligence ops. Then you have the S2. This is the heavy-duty version. It's a dual operator setup, so that 30-kilo load is split right down the middle between two soldiers. This one gives you the absolute full spectrum of coverage for conventional warfare and border surveillance. It's just a brilliant way to adapt the gear exactly to what the mission demands. Moving right along into Section 3, Anatomy of the Tech, Engineering the Impossible. Let's look under the hood. Okay, so how do you physically shrink a truck-sized system into a backpack? It takes some extreme engineering. Because different radio frequencies need totally different antenna shapes, the ELINT uses this crazy segmented hybrid antenna architecture. It literally pops out an array of 5 completely distinct antenna elements from a single collapsible carbon fiber mast straight out of the backpack. And the specs on this are wild, 30 megahertz to 40 gigahertz. Let that sink in for a second. That is a massive, massive range to listen to. In physics, the size of an antenna scales inversely with the frequency. So a 30 megahertz signal technically needs a huge 5-meter antenna, while an 18 gigahertz signal only needs a tiny 8-millimeter patch. To catch all of that simultaneously, without any blind spots, the engineers had to creatively combine electrically short antennas with active matching networks, just so a human could physically carry the thing without tipping over. But wait, how on earth do you power what is basically a supercomputer at 18,000 feet without the enemy hearing it? The workarounds are so smart. For the S1, there are literally no fans. It uses passive thermal cooling with an aluminum chassis acting as a giant heatsink, so zero acoustic signature. It is dead silent. Oh, and for the soldier safety, since you're walking around with all this intense radio gear, the backpack is lined with a mu-metal and copper mesh Faraday cage. It shields the operator from radiation, meaning they can wear this advanced tech safely for hours on end. All right, Section 4, the AI intelligence brain, going from raw signals to smart data. The hardware is incredibly cool, but the software is the real secret weapon here. Let's walk through how radio waves actually turn into actionable intelligence. It happens in 3 steps, and the entire pipeline takes less than 500 milliseconds. That is literally faster than you can blink. Step 1, the antennas capture the RF signal. Step 2, that raw data gets shoved into an FPGA, a field programmable gate array, which does all the digital signal processing to instantly extract the core characteristics of the signal. And step 3, that organized data hits an edge AI engine for immediate threat classification. So yeah, this isn't just a fancy radio. It's a cognitive brain. It's running on an NVIDIA Jetson-class neural processing unit. And what makes this architecture so powerful is that it operates completely offline, no cloud connection needed. A lightweight convolutional neural network classifies complex threats, like an incoming drone swarm or an enemy fire control radar, in under 200 milliseconds, with over 90% accuracy, right there in the mud on the battlefield. But here's where my mind was completely blown. A proprietary method called RF fingerprinting. Think of it like facial recognition, but for enemy hardware. The AI doesn't just say, hey guys, there's a radar out there. It actually analyzes microscopic imperfections in the signal, stuff like phase noise and frequency drift, to identify the exact, specific physical piece of equipment. It literally tells the operator, this isn't just a radar. This is radar unit number 47, the exact same machine we saw 3 days ago at a totally different location. It's unbelievable. Which leads us nicely to Section 5, the tactical advantage, redefining situational awareness. Let's talk about what this actually means for the troops on the ground. When you put this whole package together, the operator gets some unreal capabilities. We covered the wideband range, the RF fingerprinting, the offline AI, but it also does interferometric direction finding. That's a mouthful, but it basically means the operator gets an astonishing sub-2-degree bearing accuracy to pinpoint exactly where an enemy signal is coming from. Toss in hot swappable batteries for the dual operator system, and you've got a unit capable of running 12-plus-hour missions with zero downtime. Tactically speaking, using the SG ELINT is essentially a stealth mission. It has a 0 probability of intercept because it is strictly receive only. It never ever transmits. So the soldiers stay completely invisible while hearing absolutely everything the enemy does. At the same time, it's generating a real-time electronic order of battle, and it can plug straight into national intel grids, feeding highly secure data instantly to the NSA, RNEW, and the Air Force in real time. There's a quote from our source material that perfectly hits the nail on the head here. It says this is a system where every signal is not merely recorded, but understood, classified, and attributed to a specific emitter in real time. That is the massive takeaway you should remember today, folks. This tech literally transforms a soldier from a blind target wandering through a maze of invisible radio waves into an omniscient hunter who knows exactly who is out there and exactly where they are. Which leaves us with one final big question to chew on. In a future where the absolute deadliest weapons are invisible radio waves, who truly controls the battlefield? Because spoiler alert, it's not always the army with the biggest guns anymore. It's the one that can see, understand, and map that invisible world first. Anyway, thanks so much for hanging out with me for this explainer. Keep questioning, keep learning, and I'll catch you in the next one.